Oh, hi doing everybody. I know it has been very tough preparing for JAM nowadays. So, but LFS always got your back. So, if you always want LFS here, will find your X so that you can find your success. So, in today's video, we are going to be starting our 30-day series. So, please don't miss this particular video. We know you have 30 days to JAM, Abby, 30 days to JAM. So 30-day series. So in today's video, we'll start talking about likely JAM question. And the way we're doing it, we're not just doing like what other tutors. I'll just come and read the questions and just pick answer. We are going to analyze this particular question. So that next time when you see this particular question anywhere, you will not have an issue. So if the first time you are in LFX, so make sure you are welcome. If you are a returning subscriber, you are welcome back. So in today's video, we are going to start with this question. So the first question on the board is, what happens to the position of equilibrium if a reversible exothermic reaction is subjected to a decrease in temperature? What happens? So they gave us option A, the position of the equilibrium shifts to the left. B, the position of equilibrium shifts to the right. C, the position of equilibrium remains unchanged. D, the reaction stops. Now, this particular question is not a question that if you see it in JAM, you start having an issue. So before we start answering this question, I bet you will be the one to answer this question after my explanation. Now let's now talk about what we now talk about. What is equilibrium now? First of all, but let's just talk about the Lachaise principle first. And most of you have already known the basis of equilibrium. Now, and the basis of equilibrium, you have to have it in mind that when this, first of all, an equilibrium, before you know a reaction in equilibrium, you have to have this, which means what? A reversible what? Reaction. And when we talk about that, a system or a reaction is at equilibrium is when this forward reaction is equal to the backward reaction. When this is happening at the same time, that means that particular system is in at what? Equilibrium. Now, Lachaise now stated a principle and told us that when a system is stressed, let's assume that a system is stressed. A system, some certain factor is what is touched in a system. That particular system will move to the other side in order to balance that particular distance. Now let's now assume let's have a boy now sitting here. Let me give you an example. The boy is sitting here enjoying himself, and the boy is sitting here enjoying himself. We have something like this. Now, what do you think will happen when this particular ball will move? This thing will move like this, Abby. Do you understand now? This thing will move like this. But in this particular situation, what if this particular person now wants to balance this now? This particular person wants to leave, and maybe there was a signal that this person wants to get up. What is that will happen? This person will shift to this particular place in order to balance this thing. Where did he shift? He shifts to this side in order to balance this force. I don't know whether you understand what I said. I said that what if this ball wants to go out? As this boy wants to go out, another person is sitting here. And when this particular person wants to go out, and he now have that, he now see that this person now notice that this person wants to go out. What is going to happen? He's going to shift to this particular side in order to balance this word force. That's what is going to happen. Now that is major small African destiny of what Lachaise is telling us. Now, there are some certain factors that affect a system in an equilibrium, a reaction in equilibrium, and one is what? Temperature. We have temperature. We also have concentration. We have pressure, and we now have catalyst. So I'll just give you the brief listing of how all those things affect the destiny now, affect a system in an equilibrium. Let's now have it in mind. In temperature, if a particular system, the temperature is increased. If the temperature is increased, what do you think will happen to the heat first? Let's just have it in mind. If the temperature is increased, what do you think will happen to the heat? The heat will also increase. So let's have it in mind. We'll have A plus B giving us this. This giving us this. And the temperature of this reaction will increase. The temperature is increased. If this particular system is an endothermic reaction, this particular system will move to this side to balance it. To balance this particular distance. So it will move to this right side, favoring what? The forward reaction. Let's take something for instance. Let's assume that this particular system, what it was using to react, the particular distance now, the energy that this thing has before is 12 joules. 12 joules. And now, they now increase the temperature. If they increase the temperature, what do you think will happen? It will absorb more what? Energy. And then let's assume now move to something like 15 joules. Now this system was in an equilibrium before. That means if here was 12 joules before, here was 12 joules before. So if you now increase this thing to 15 joules, it will move to this side to balance this thing, because here we'll have the higher energy, here we'll have the lesser energy. What will happen is that this one will move to this right hand side, so that here will now be something like, let me just say, here will now move to, let's just use 16. So that you now have, what will happen here is that here was 12 joules, here was not 12 joules. What do you think will happen here? They will share the what? 4 that is on top of this. Here will now become how many? Here will become 14 joules. Here will now become 14 joules. What do you observe? The temperature here was increased. The energy here became what? Increased. So for this particular system to become balanced as how it was before, the system has to move to the forward, to this particular side in order to balance it. Now let's now have it in mind. This happens in what? In endothermic reaction. Endothermic reaction. The endothermic reaction, where energy is what? Absorbed. Where energy is what? Absorbed. Now, what of if the energy here was decreased? That means, let's assume that it's decreased from 12 joules to 10 joules. What do you think will happen? Do you know here we'll have the higher 12 joules now? What do you think will happen? This thing will move from this particular side to the left hand side, favoring what? The backward reaction. I'm using simple sentence to explain this, because JAMB is all about understanding what this thing means. That's why I'm using simple terms. Now, we have this one now moving to this. Here will now become 11 joules. Here will now become what? 11 joules. That means it has moved from here to here, favoring the what? The backward what? Reaction. Do you understand now? Now, what of if this thing was now in exothermic reaction? Exothermic reaction is opposite of what happens in endothermic reaction. Opposite. Remember, in exothermic reaction, heat is what is released to the environment. So opposite of what happens in the what? Endothermic reaction. What is opposite of what happens in the endothermic reaction? The opposite is that if you increase this particular energy here, the distance will move to the what? To the right, to favor what? The forward reaction. But in that exothermic reaction, if you now increase here, what will happen? And if you increase the temperature here, this one will move to this particular side to favor what? The backward reaction. It's opposite. It favors the backward reaction. For this particular question, they don't say what happens to the position of equilibrium if a reversible exothermic reaction is subjected to a decrease in temperature. So one is that the position of equilibrium shifts to the left. Remember, they are talking about, look at what they say, exothermic. Remember, I said exothermic is opposite of what happened in endothermic. Now, the position of equilibrium shifts to the right. C, the position of equilibrium remains unchanged. D, the position of the reaction stops. What is now happen? Remember, I said the opposite of what happens. Remember, in endothermic reaction. Remember, in endothermic reaction, if you increase the distance, it will move to the right. That means if you decrease the exothermic reaction, it will now move to the what? To that particular what? Right. It will now, if you decrease for exothermic, it will move to the right. But if you increase for endothermic, it will now also move to the right. So the answer is what? Is B. The position of the equilibrium shifts to the what? Right. Now, let's go to number 2. In number 2 question, which noble gas is radioactive and is produced as a decay product of uranium and what? Thorium. Now, all these things that is written here is a noble gas. But all of them, none of them is a what? A radioactive element. Argon is not a radioactive element. Krypton is not a radioactive element. The only radioactive element here is what? Is radium. It is produced when what? The uranium decay and also the thorium decay is going to produce what? Radium. So radium is the answer, which is what? C. Now let's go to number 3 question. We have, what is the valency of an element with the electronic configuration 287? If you have this particular question, so what I'm going to have in mind is that I'm going to just give you a simple cheat code. Simple cheat code. The cheat code is that this 2 means the lowest shell, that's first system, which contains 2 electrons. This 8, this 1, which contains how many electrons? 8, according to what you have there. Here is how many? 7. Okay, I didn't write option for this, but we are going to write the options now. Just have it in mind. We have this, we have this, we have this. We have this, we have this, and we have this, which is 7. Now the simplest cheat code before I write the option now is that, look at it, we have already drawn this now. If the electrons are the atomos shell, look at the cheat code now. If the electrons are the atomos shell is more than 4, is more than what? 4. First thing to do is for what? Use 8 to minus it, so you can get the valence number. Did you get what I said? I said use 8 to minus it. So now, what do you have here is what? It's 7. That means if you have 8 minus 7, is how many? Is equals to what? 1. But if the electron in the atomos shell is not up to what? 4, what will you do? Just write that particular thing as their what? As a valence number. For example, if you don't want to go through the stress of this, what will you do? You just say 8 minus 7 will give us what? 1, and that is your valence number. Thank you very much for showing our episode. Hope you enjoyed your episode 1. We are going to do this. We are going to bring all this your this thing. We do it this thing in physics. We do it together. See that I'm teaching you in easy way, simple way. Just what you are going to do is just click that subscribe button, like, share to your friends. We are doing it an easy way. JAMB is all about understanding. It's not about cramming. That's why we break these things in what? In layman way, so you can be able to understand. So anyway, you see this type of questions in another place, you are going to enjoy it. Thank you very much. I salute you. Always remember that LFS will only help you to find your X. That's what will help you to also find your success. See you next time. Thank you very much.